We're doing implicit differentiation. What implicit differentiation means is up until now, we've always differentiated with respect to x. Now we can differentiate with respect to both x and y. That's what differentiation, that's what implicit differentiation is. For example, if I had y equals 3x squared. Dy dx would give me 6x. There. That's what we've been doing. But now, what if we had equations like this? That's an example of a circle at radius 2, it's centered at the origin. So this was then, this is now. With what we know so far, we can't really differentiate these, a lot of these. Well, like for this one, we could solve for y. Y would equal plus or minus the square root of x squared minus 4, or negative x squared plus 4. But what about this one? We can't get y by itself. Because of that, now we have to use something called implicit differentiation, where we take derivatives of both the x and the y. So here's an example. Here's example 1.
So if you can't get y by itself, you have to take the derivative of both the variables. Or both x and y.
Yes and no. It's that there are certain instances, cases where we need to use different implicit differentiation. But yeah, that's one of them, because what we're looking for dy dx. That's the derivative. So yes, if on one side it has x squared or x cubed minus or y cubed minus y squared, and we really can't do anything about that. So we have to do implicit differentiation. And then I'll show you how we get dy by itself. All right, if in the past, what we would do is we had this, what we would do, we take the square root of both sides. So y would equal plus or minus square root of x. Yes, but that doesn't do us too much good, because what is that graph going to look like?
Square root.
This one here. Well, yeah, but it's plus or minus. The square root function looks like this. The negative of it is like this. So it's defining a hyperbola. It's not a function because it fails the vertical line test. So again, now we have a problem with that. How would we still take the derivative of this? So to take the derivative of it, I'd have to take the derivative of that one, and I'd take the derivative of this one. So what's the derivative of square root of x? subtract one, so it's negative 1/2, which is 1/2 radical x. And do the other side, the negative square root of x. But that's a lot of work. So now, in implicit differentiation, when you take the derivative of x, you do it the same way you always do. Whenever you differentiate y, you must place a dy dx afterwards. So this is where your dy dx comes in. Why? Because y is still a function of x. So let's look how we do this one now. Let's do this one instead of doing this long way we did here. Let's do it implicitly. On the left side, we separated the x and y's. So take derivative of y here. It's going to be what? 2y times the derivative of y is 1 dy dx. You still use the chain rule. But after we take the derivative of y, we put dy dx after it. What's the derivative of x? Now we solve for dy dx. Divide both sides by 2y. So we have 1/2y. What is y? We have to solve for y. So we have 2y. We have to figure out what y is. Y is plus or minus square root of x. So our answer is this.
You're doing it in a kind of roundabout.
And much faster because we had to do these 10 steps separately to do this one in 3 steps. So yeah, it is a roundabout way. It's a more direct way. It's a faster way. Because whenever you take a derivative of y, if it's a power of, or anything that, you'll still have a y function. When you move everything over to one side to get dy dx by itself, you still have to tell me, what does y equal? And that's where we have to go from here to there.
And we know at what.
Yeah, now we know what y equals. So the derivative, so the first derivative is plus or minus 1/2x, 2 radical x. Okay, let's look at example 2. Find the slope of the circle x squared plus y squared equals 25 at the point 3, -4. Next sheet. So how do we find the slope? Yeah, the slope is dy dx.
So in this case, we can get y on one side. So do we get y on one side?
Actually, or since it's not combined x and y, we could just take them both independently.
Okay.
But you're right, yes. We could have moved the x squared over there and take the derivative of both sides. Because all we're looking for is this, and when we'll leave the answer in terms of x and y, because that's what we started off with. And we have an x value and a y value. So what's the derivative of x squared? The derivative of y squared? No, not 2x.
Or I mean, yeah, 2y.
2y.
Yeah.
2y.
Uh,
You're not done yet. You're not done yet. Nope. Still not finished.
Oh, plus.
Whenever you take a derivative of y, you have to put a dy dx afterward. So now solve for dy dx. Subtract 2x, so we have 2y dy dx equals -2x. Divide both sides by 2y. The 2's cancel, so we have -x over y. Again, this is the first derivative, which is also the slope. At the point 3, -4, the slope is -3 over -4, or 3/4. That's the slope. And we do it with trick one. You're looking at it, like it's got 3 eyes.
Oh, yeah, I was just, seeing the points.
Yeah, and that was the original question. So we had this circle at that point. And that's why we'd leave it as x and y. Okay, let's see, we're ready for the next one? Or still scribing? Wait. Get this stuff out of here. Example 3. Find dy dx if y squared equals x squared plus sine xy. So we have to use a chain rule. Actually, the figure here would be squiggly lines like this. Okay. The derivative of y squared. dy dx. You cannot, that's gonna be so easy to forget. It's the same as at the beginning of this course when we had to put limits in front of all the steps. You forget those till the very end. Okay, x squared. Because it's already divide derivative of x, so leave it now. Yeah, xy is equal to u. So du, let me put it over here. U equals x times y. So du would be yeah, so it's cosine xy times, we gotta use the product rule. So we have x, y, derivative of x is 1. Derivative of y is what? It is 1 because times dy dx. Since it's a product, we add. So it's going to be y plus x dy dx. Y plus x dy dx. Okay, so now we do now. What are we solving for? What are we solving for? We're looking for dy dx. So we have to get this dy dx and this dy dx together. So we have 2y dy dx equals 2x. Since this is multiplied, plus y cosine xy plus x cosine xy dy dx. What next? We have to get all the dy dx's together. Do subtract x cosine xy dy dx from both sides. We have 2y dy dx minus x cosine xy dy dx equals 2x plus y cosine xy. Those are gone. Let's see what example 4 is going to be. Okay, yeah. So what do you do next? Remember, we're trying to get dy dx by itself.
Factor.
Very good. Very good. A lot of people don't see that. Since we're looking for dy dx, they're both the same. So we're left with 2y minus x cosine xy equals 2x plus y cosine xy. So what's next? Divide both sides by 2y minus x cosine xy. And there's your slope. Yeah. It looks so benign when you get, I mean, it's a very small, easy question, but now look all the work we had to do. So far, so good. Now, example 4. What is this one asking me to do? But what does this mean? What am I looking for? Second derivative. Yeah, because whenever you have that, that's the nth derivative. Right, so we have to find the second derivative. It sounds simple, yeah, I do, but we have to usually find the first phase to put in the second phase. So let's look at this. So we have 2x cubed minus 3y squared equals 8. This is our first one, call it A. Take the derivative of it. 6x squared minus 6y equals 0. Right? What do I do next? Right, you have to put a dy dx right there. Can't forget. Let me get myself a little foam ball to throw at you guys. Okay, so the first step. Take the first derivative. And solve for dy dx. So we have to subtract 6x squared from both sides. Negative 6y dy dx equals negative 6x squared. I'm giving you guys this as a simple advice, but you don't have to do it if you don't want to. Whenever you get in this part, I know you guys are gonna say divide both sides by -6. Never divide by negative. Because you'll have equal signs, you'll have signs in the equations, you'll have everything. Always change the signs first across every term. Basically, yeah. So it's much easier. Instead of doing that, just go across the board and just change everything. Yeah, it's what you're doing. So change all the signs. Now divide by your coefficient, 6y. The 6 is canceled, so we have x squared over y. Now what do you do? Yes. So we will need this later on. Step B. Now, find the second derivative, which is d squared y over dx squared. No. It's a quotient rule.
So,
So x squared and y. So derivative of x squared is 2x. The derivative of y is dy dx. And since it's division, you subtract. So the second derivative y times 2, so it's 2xy minus x squared dy dx all over y squared. Are we done? No. Why not?
we have to.
Yeah, we know now we have a dy dx. So what we found in the first derivative, plug it in there. 2xy minus x squared. Dy dx is x squared over y. So put the x squared over 1 and 2xy over 1. Because we need to get common denominators. So in this first one, we need to multiply by y over y. X squared times x squared is x to the fourth. You add the exponents. All over y squared. So it's 2xy squared minus x to the fourth over y, all that over y squared over 1. So leave the top alone. We have 2xy squared minus x to the fourth over y, and flip the bottom. And that is your second derivative. What's that? No, because if it's y squared over one, you flip it to one over y squared. So far, so good? So yeah, you can keep on going as high as you want to, how many derivatives you want. But in the next derivative, we take it, find for the third derivative, we would have a part that has x, the second derivative and the first derivative. So anytime you take one, you have to keep on bringing the other ones back.
So it's kind of like an iterative process.
It very much so, yes.
And you're adding each new derivative.
Right.
To it.
And then you always refer back to, for the first derivative, it's x squared over that. The second derivative, you have to put this in its place. So you see how it gets bigger really quick.
And would you, if you're trying to find, some high-end derivative, would you just do that to like a algebra, like the TAS system?
Yes,
You just,
depending on how, yeah, because it just explodes from there.
But so like for advanced applications, you just use, they're called like algebra systems? Complex algebra systems? The CAS?
Is that was, yeah, complex algebra systems.
Yeah, complex or something like that.
But yeah, you
I've
just,
never, I just know that you use those for more advanced applications.
right, and that's just, anything higher than that, I would definitely use that.
Otherwise, it's just getting messy.
Oh, it gets very messy very fast. Okay, let's see. This last section deals with lines, tangent lines, and normal lines. Yeah, that's. So. Where's example 5? Oh, well. Let's look what we have. Let's find the tangent line. And we'll talk about normal lines in a second. So how do you find the tangent line?
You have to find the derivative and set it equal to 0.
You know, because dy dx is the slope of the curve at a given point.
And when it says normal, it means perpendicular.
Perpendicular. Yeah. So once we find the slope, then we have to take the negative reciprocal of it. So our first derivative is 3x squared yes, you didn't forget it then. Minus. Now we gotta do the product rule. If you want to, if you're sure you won't get too confused, you can always, instead of dy dx, you can put y prime. But like right here, it'd be a problem. It'd be y squared y prime. You think, now is it y to the 1 or is it y prime? Very easily. So then we have y plus x dy dx equals 0. Remember, the first phase is find the derivative of each of them and then solve for dy dx. Well, we have to set it up first. Because we have to distribute that in there. We have to get rid of that parenthesis. Now you get rid of everything that's not dy dx on the other side. So on this side, we'll keep 3y squared dy dx minus 9x dy dx equals negative 3x squared plus 9y. Then what do we do? We're trying to get dy dx by itself, so we have to factor it out. And then divide both sides by 3y squared minus min x. So dy dx is equal to negative 3x squared plus 9.
Shouldn't be plus nine.
Hmm?
Nine plus dy dx, right?
On which one?
It's the, when you plug in the, you did the X one. Plus nine, right?
Because here was a negative 9 coefficient, so I
Oh,
distributed.
yeah.
Okay, remember, the question says that show that the point 2,4 lies on the curve, then find the line tangent. How do we, oh, we never did that. How do we show that this point's on this curve? Plug it in and see if it equals 0. So we have 2 cubed plus 4 cubed. 9 times 2 times 4. 8 plus 64.
72 minus zero, 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 zero.
Yeah, so 72 minus 72 equals 0. So yes, it is a point on the curve. Because if it's not on the curve, we're done.
So, well, it's a good thing it was.
Yeah.
I guess it's a good thing it was.
But it's typically, and I should have read the rest of the instructions. Because yeah, that's a good trick that people do on tests is they just assume it's on the point. Because if it's just a point out here, there are infinite number of slopes that goes through it. So, yes. But that would be a good trick final exam question.
Yeah.
Okay, so now we do. We have this. We know it's at the point.
Pretty good for us, not the people who are in the class right
Oh,
now.
yeah, exactly. All right, so now what do we do? The tangent slope. The slope of the tangent at 2, 4. Just plug them in there. So dy dx is equal to negative 3 times 2 squared plus 9 times 4 over 3, 4 squared minus 9 times 2. -3 times 4. 9 times 4. 3 times 16. -12 plus 36. 48 minus 18. (24 over 30). 6 goes in there 4 times, 6 goes in there 5. So it's 4 over 5. So then find the tangent and normal to the curve. Oh, okay. We have to find the equation of the line tangent. The line tangent is
So, I mean, it's 4 over 5, so
at the 0.24. So we have 4 equals 4 over 5 times 2. Get rid of the. I like to get rid of the fractions because we could do 8 over 5 and no worry about that stuff. I will get rid of the fractions. So I'm gonna multiply everybody by 5. 20 equals 8 plus 5b. Subtract 8. We got 12 equals 5b. So b equals 12 over 5. So y equals 4 over 5x plus 12 over 5. That's the equation of the line tangent. How do we find the normal curve now? The normal line. Yep. What do we know so far? We know dy dx is equal to 4 over 5. That's the slope of the line tangent to the curve. At 2, 4. So the slope of the line normal or perpendicular to the curve at 2, 4 is perpendicular is negative reciprocal. So it's -5 over 4. We have to change the sign and flip it.
then that will give you.
slope. And the point is still the same, 2, 4. So y equals mx plus b. We don't know what b is, so we have to plug that stuff in there and solve for b. 4 equals negative 5/4 times 2. The 2 and the 4 cancel. 4 equals negative 5/2 plus b. Get rid of the fraction, multiply each term by 2. So those cancel. We have 8 equals negative 5 plus 2. This is the way I do it. You guys don't have to do it. You can do it. If you like fractions, you can keep fractions.
Yeah.
8 plus 5 is 13. Equals 2b. So b equals 13/2. And m equals negative 5/4. Negative 5/4x plus 13/2. And that's it. Very straightforward. Yeah, implicit differentiation is a lot of fun. I enjoy that a lot.
It is fun. I feel like I'll really get it down after, a bunch of problems, doing, obviously the way we learn math, we can do more problems.
Well, let's do another one. I shall make one up.
So that's always gonna be the case to find the normal.
Yes, normal is always perpendicular and just flip the tangent line. The slope tangent, right? Negative reciprocal, right?
Okay, that's.
3x to the 4th minus 5y to the 3rd plus cosine 2xy equals 3. Find me the slope of that function. At 3, -1. Go ahead and work that out. Okay, so the first one. What's the derivative of this first part?
12x³ minus 15y² minus dy/dx. dy, yeah, it's not dy. Plus, we know it's gonna be minus or minus sign.
Use. So
U
we,
equals 2x.
we do the product rule.
Oh. So
Equals 0. Okay, then what do we gotta do?
Distribute.
Yeah, get rid of the parentheses. Well, first off, we have two signs next to each other, so it's gonna be minus. And then distribute, right? Minus sign that times 2y, so it's minus 2y sine 2xy. 2x.
Oh.
Try not to look what I'm writing. Do it yourself and just use mine to check. Don't just bobblehead. Now we gotta separate the dy dx's from the non-dy dx's. Yeah, we'll move the dy dx's to the other side. Then
Is it right if I put 2x times dy times sine 2x?
no. I mean, it's right. It's commutativity. You can move them around.
Okay,
I like to put dy dx at the end.
oh, that's what I figured. I thought I just had it in a different order. Okay,
Yeah,
so then we
Because of
factor-
commutativity, you can move them any way you want to.
Okay, and then we just factor out the dy dx.
Right.
Oh, it's just, okay, that's it. Then we're going to divide both sides by 15y squared plus 2x sine 2x.
Correct.
That's another big slope.
Okay,
That's, I'm not done yet. So I'm gonna plug in. So 12x, or I'm sorry, 12 times 3 to the power of 3 minus 2 times -1 sine 2, 3 times -1 over 15 times -1 squared plus 2 times 3 sine 2 times 3 times -1.
Question because I didn't even sure put the what's it like dividers on this side,
Mhm.
right side.
Yeah.
Because that's why it's both negative.
Well, yeah, it's
So
and-
are we going to change?
it's gonna give us, and that's why I said, that's why I like it when we put numbers in there. Once you put numbers in there, you'll get the same numbers.
Oh,
So yeah, we'll see, we'll get the same numbers, no matter where you put them. So 3 cubed is 27, so 27 times 12. 54. 324. Don't keep on, work it out yourself. You're just copying me. Work it out yourself and see what you get. Okay. Well, then there's nothing to write. I mean, it's either gonna be the same or different. There's nothing more to write. Yeah, so once you plug the numbers in there, it makes it much easier to look at to see if it's correct or not. Because yeah, that's just a lot of X's and Y's.
I try, I always try to. This is really, I'm better at doing the computational stuff.
Well, see, and it's just mechanical. And that's why we spent so much time at the beginning of the semester with the algebra. And because you see why, it's, you need to have it, it has to be muscle memory.
I almost wanna get like a chalkboard for my revision, just because I do it on here, but I'll run out of space. And like on a whiteboard or something, I can just keep going.
And for that, you don't even need a chalkboard. You get just any plastic pretty much and use a dry erase. So, or what I do in my office, well, I hear another office, I have my windows from top and bottom. I use the windows as
Oh, that's a good idea.
just write it down. Because then you're also cleaning the windows at the end.
So it's like you don't even have to do work.
Exactly, yeah. You're studying and working at the same time. So yeah, if you have a big window somewhere or even a mirror, just do that. And
Yeah, mirror would be-
if you need dry erase markers, I can get you some.
Oh, it's, yeah, I have some.
Okay.
I had a whiteboard once, but when I moved, I left it by accident, and then I was all out of that, so. It wasn't like anything crazy nice or anything, but. I had a package, but it is nice to have a big